angle between two vectors. Angle between two vectors. So here we have learned how to find the magnitude. So there we also need. Let's say I have a vector A and B, for example. Let's say I have vector A and B, and I want to find the angle between them. So that one is just a formula that you need to know. So the formula that we normally apply is cos theta is equal to A dot B divided by absolute of A, then absolute of B. You see? A dot B, is it cross product or dot product? Yeah, it's dot product because we have done the dot product in the previous examples. Then the one we just conclude now is how to find the magnitude of how to find the magnitude of two vectors. I'll find the magnitude of the two vectors maybe for the A at the same time for the B. Then find their product, then divide it by the value that we have in that particular problem. So let's say, for example, maybe we are given that. So don't forget, in the previous example I saw for the magnitude, we might be given 3. Even if you are given like, let's say I will given like x is equal to 2i plus 3j plus 5k. And I was asked to find the magnitude. You see the same thing. Magnitude of x is going to be square root of 2 squared plus 3 squared then plus 5 squared. So it depends, either 2 directions or 3 directions. You follow the same process. Now, here, if I want to find the angle between two vectors, the first thing I will do, I'll find my A dot B, meaning I'll find their dot product. You know, they call the condition for the dot product. If I have I dot I is 1, if you have J dot J is 1, if you have K dot K is also 1, but if they are different, that's going to be 1 is going to be 0. So then I'll find the absolute of the first one, get the absolute of the other one too, then I'll find their what? I will divide it and find the cos inverse of the two. Let's say, for example, if vector A is equal to 2i plus, okay, let me just give a standard value to save our time, 3i plus 4j. Let's say vector B is 6i plus 8j. They now said find the angle between A and B. So what did I need to firstly do? I'll firstly find my what? My A dot B. Very nice. A dot B. So my A is 3i plus 4j. Don't forget, they used to put cap for the vector. So dot. My B is 6i plus 8j. So I will take it direction by directions. That's going to be 3 times 6. We are going to have 18. Now 4 times 8. We are going to have 32. You know, I told you don't to waste your time by saying 3 times this, 3 times this. Because by the time you multiply 3 by 8, you know, we are going to have I dot j. And I dot j is nothing but 0. So 18 plus 32 here, if you add them together, of course, you are going to have 50. Because 18 plus 32, we are going to have 50. So we have gotten our A dot B. So let's find the absolute of A. That's going to be square root of our A is that is 3 squared plus 4 squared. So here we have square root of 3 squared. You know, 3 squared is 9. 4 squared is also 16. Then if I add this one together, definitely we have 25, and square root of this is going to be 5. Now the other one we have for the B, let's find the magnitude of B. That's going to be 6 squared plus that's going to be 8 squared. So this is nothing but 36 plus 64, and that one is going to give us 100, and that one is 10. So that way we have gotten all the data that we needed here. So I'll just go to the formula. Cos theta is equal to A dot B divided by absolute of A and absolute of B. So now let's substitute what we get in each values. I can have cos theta equal to A dot B. What do you get for A dot B? You can see our A dot B we have 50, right? Yeah, good. I have 50 divided by absolute of A. What do we have for absolute of A? Absolute of A is 5 multiplied by absolute of B. What do we have there? We have 10. Good. So here we have cos theta is equal to 50 divided by 5 times 10. Of course, we are going to have 50. So how many 50 can we get in 50? 50 in 50, what are we going to have? and 1. So now, what we are looking for is theta, not cos theta. Then I can have my theta to be cos inverse of 1. So please check your machine. If you check cos inverse of 1, what I have here is 0 degree as the result. So it doesn't matter. In some problem, we don't have 0. Let's take a look at the question that we have from Federal University Duse here. In their questions, we are given that, let's see the questions. Let's look at this problem. So let's see how we are going to go with that and see how we are going to approach it. They said two vectors, question 2, two vectors A and B are given by A equal to 2i minus 3j plus 5k, and vector B is given by minus 6i plus 9j minus 15k. They now said, find the angle between A and B. Find the angle between A and B. So we are going to follow the same process and the same pattern of how we do that. So now, the first thing, let's finally find their A dot B first. You remember, A dot B means we have to find the dot product of the two. A dot B now. So the vector A is given as 2i minus 3j plus 5k. That's vector A. Dot vector B, we have it to be minus 6i plus 9j minus 15k. I told you for the dot product, just be taking them direction by directions. I for I, j for j, at the same time, k for k. So here, 2 times minus 6 now, that is going to give us a minus 2, because the value that we have here contains negative. Now, minus times 9, we are going to have minus 27. The last one, plus times minus, and we have minus 5 times 15. Definitely, we are going to have 75. So if you press this, I think we are going to have minus 144, right? So let's check. The first one, we have minus 12, minus 27, minus 75. We have minus 114. Very nice. Minus 114. So now let's find the absolute of A. Absolute of A as usual, just like taking the square root of the value given. So the first one we have is 2, and it's 2 squared plus minus 3 squared plus 5 squared. So here we have 2 squared, that's going to give us 4, right? So minus 3 squared, minus times minus, we are going to have plus. That's why we did not have any negative here. So minus 3 squared, we are going to have 9, then 5 squared, we are going to have 25. So 4 plus 9, and we have 13. 13 plus 25, we are going to have 38. That's for the first one. Now, for the second one as well, let's go for B also. For B, we have minus 6 squared, the first one. The second number, 9 squared, and the third number, we have minus 15 squared, right? So don't be confused about the negative, because by the time you square the numbers, minus times minus will definitely become positive. So minus 6 squared, we are going to have 36. Then 9 squared, we are going to have 81. Minus 15 squared, meaning minus 15 times minus 15, and definitely we are going to have 225. So let's see that. Plus 81 plus 36. All we have is a square root of 3, 4, and 2. So I've gotten all the data needed. I've gotten A dot B to be minus 114. I've gotten absolute of A to be root of 38. Absolute of B to be 342. So the next thing for me to do now is to find my angle as required. So from the problem, we are asked to find the angle between A and B. So please, it might be anything. They can use X, they can use Y, they can use W, they can use X. Whatever they use, just follow the same process. Assuming they use X and Y, we just have cos theta is equal to X dot Y divided by absolute of X and absolute of Y. So now, if I go to the formula, I have cos theta is equal to A dot B divided by absolute of A, absolute of B. So my A dot B, I got minus 114. Absolute of A, I have root of 38. Absolute of B, I have root of 3, 4, and 2. So here, definitely here, I can have minus 114. You can see the first one and the second one have roots, right? So since the first one and the second one have roots, you can just multiply the number that we have inside the root together. So here we have root of, now 38 multiplied by 342. If you do that, you are going to have 1, 2, 9, 9, and 6 here. So the next thing now, I can just find it. If you like, from here you can say theta is equal to cos inverse of your result, 114 divided by square root of 12996. You can, if you do that, you are still going to have your result. So shift cos inverse of minus 114 divided by 12996. So if you press that, what I have here is 90.5. So please check that one. It's a simple exercises to confirm your result. Sorry. Hello? Now? So, what's the problem? Yeah. So, if you check a calculator for that, if you check it, you get your result. Just requiring, I will not take the answer so that you just find out on the simple exercises. Just try to check if the value you have is still going to give you the same result as mine. Then I think you are going to get 9 something, but I will not tell you that one. So now, so that's all about the angle between two vectors. So the next one we have is the next one we are going to talk about is resolution of vectors. How can we resolve when we have more than two forces, two vectors in the plane? So you know we have two planes, resolution of vectors. Resolution of vectors or component of the vectors. So in that one, I will teach you how to find the magnitude, direction of it using the law of quadrants. You know, normally we have two planes. We have vertical and we have horizontal. This area is very, very important. I know this is y-axis and this is x-axis. So if I'm resolving a force on the vertical, this is vertical, we call it vertical axis. Here we call it horizontal axis. Okay? Now, if I'm resolving a vectors, in any of these two, mostly, depending on how they give the problem, but mostly, if I'm resolving a vectors or a forces through vertical, we're making use of sine. So you need to have this on the back of your mind. If it is horizontal, I'll be making use of cos. Please take note of that. If I say f of y now, that means I'm referring to the force under y-axis, which is a vertical. If I said f of x, that means I'm talking about the force that is resolving in where? In the horizontal. So please mind you, if you are resolving a force to the vertical, mostly we use sine theta. Then for the horizontal, we use cos theta. So please, this is very, very important that we need to take note of. So now, how can we now break the quadrants? Let's break the quadrants. So I even break this one in for mathematics, so we can just try to check our previous videos under the components. I think under trigonometry, how we normally break down the component. So let's see. Let's see how to approach that. Now, so please, this is very, very important, and I will break it down so that you can understand how we normally resolve a force or a vector. Either it is 2 on a component vector, either it is 2 forces, either 3 forces, either 10. I will give you a simple logic of how to do that. So please just follow my method. Now, you see, the quadrant is like this. That means it's 4 quadrants. First one, second, third, and fourth. We normally resolve the quadrant. I would normally read the quadrant anti-clockwise, just like this one. You can see it's not like this way. So just like what we have here, the angle we have here is 90 degree. 90 plus 90 is 180 degree. This is 180 plus 90, and we have 270 degree. 270 plus 90, and we have 360 degree. In the first quadrant, meaning any angle from 0 to 90, either sine theta, either cos theta, either tan theta, all are positive. Meaning sine is positive here, cos is also positive, at the same time tan is also positive. Any of these three that we have, either we have sine, either we have cos, or either we have tan, all are positive. In the second quadrant, only it means any angle from 91 to 180, only sine will be positive. That is, in the second quadrant, sine is positive, cos is negative, at the same time, tan is also negative. So in the third quadrant, any angle from 181 to 270, only tan is positive. Only tan is, that means tan is positive here, sine is negative, at the same time, cos is also negative. So in the last quadrant, only cos is positive, meaning cos is positive, sine is negative, at the same time, tan is negative. But you know, this is medicine academia. You don't need to be cracking your brain. I will give you a simple acronyms on how you can master this simple law. I will give you a simple acronyms. Once you know the simple acronyms, no matter how you want to do the quadrants, just master that one. Just follow it this way. All science take chemistry. All science take chemistry. It's a simple acronym of reading the quadrant instead of cracking your brain. You don't need to crack your brain. So now, all. It means in the first quadrant, all are positive. If you go back here, you can see I said all are positive here. You see the second one, we have signs. You know, when I was explaining, I said in this quadrant, only signs are positive, right? So that's why we have signs here. That means in the second quadrant, only signs are positive. So can we check the third one? Take. That means which one is going to be positive there? Yeah, good. So that is only tan. You can see when we are explaining, we said only tan is positive here. Then the last one, without being told, that one is what? Yeah, of course. Very nice. So you don't need to crack your brain, cramming it. No. So just master this simple logic. All science take chemistry. Meaning in the first quadrant, all are positive. Science. In the second quadrant, only sine is positive. Take. Only tan is positive. C. Only cos is positive. So we make use of the knowledge of the quadrant, the knowledge of these acronyms to solve a problem resolving the forces. So now let's break down how we normally do that now, so that you know how to find the resultant with vectors, at the same time how you can find its directions. Look at this. Let's say I was given a problem like this. Let's say we have, let me just give a problem like, let's say we have F1 here, I have theta 1, I have F2, we have theta 2, we have theta 3, we have F3, we have theta 4, and we have F4. So even if the angle you are given is not complete, the logic quadrant is 90, so it must touch the horizontal if you want to use cos and sine, irrespective of the horizontal and vertical. So how will I do this one? Each forces I have here, I will resolve it vertically. At the same time, I will resolve them horizontally. Don't forget, we are using these acronyms. All science take chemistry. All science take chemistry, right? Yeah, good. So we make use of the quadrant. We say this is the first quadrant. All are positive. Second one, third, and fourth. And I told you if you are resolving, we have to know that one too as well. I told you if you are resolving a vector or a positive horizontal, you'll be making use of cos. And if it is vertical, you'll be making use of sine. Now, so let's see how we're going to do this. It's very simple and straightforward. Let's see if I have a diagram like this. You can, anyone you like, you can see this is horizontal, this is vertical, anyhow you put it. Maybe I say this is horizontal. You know, horizontal is for x-axis, and I'll be using cos. So this is vertical, and I'll be using, this is y-axis, I'll be using sine. Cool? Nice. So the first one, this first one, I will resolve it horizontally. At the same time, I will also resolve it vertically. So if I'm under the first one now, I can have this one to be, you know, it is cos, right? I can have it to be f1 cos theta 1, meaning I'm under the first quadrant, this cos. You know, if I'm resolving it horizontal, I'll be making use of cos. That's f1 cos theta 1. So if I'm under the vertical now, what are we going to put there? That's going to be f1 sine theta 1. You can see the only difference between them is horizontal is cos and the vertical is sine. So let's check in the first quadrant. Are they both of them, are they positive? Yes, of course, because we said in the first quadrant all are positive. That's why I did not put any negative for the two of them. So let's go to the second one. You know, this second quadrant, which one is positive here? Only what? Yeah, only sine. So that means here, if I firstly put it, f2 cos theta 2. Here too, I can have f2 sine theta 2. But now in this quadrant, only sine is positive according to what we have here. So that means I have to put minus here. You get that? Yeah, good. Because in this quadrant, under the second quadrant, only sine is positive and the cos must be negative. Now, let me put the chemistry here so that you not confuse us. Science take chemistry. Now, please check. Is it working? Is the mic working?
Yes.
Yeah. So now, let's check the third one. We are under the third quadrant now. In the third quadrant, we know we said all signs take, which means under the third quadrant, which one is positive there? Yeah, tan, because under the third quadrant, only tan is positive. So here, as usual, horizontal, we have f3 cos theta 3. And here too, we have f3 sine theta 3. Now, let me ask you a question now. Which one are we going to put the minus there? If I ask you, if you are asked that, which one of them we have negative? The both? Yes, that means you are following. Because why is it both? Because under the quadrant, only tan is positive. So that means that we have minus here. And also, I will also have minus here. So now, let me check the last one, the last quadrant. Under the last quadrant, only cos is positive. So here we have f4 cos theta 4. Here too we have f4 sine theta 4. But in this quadrant, cos is positive here. And tan must be negative. So I'll just put the minus here. You understand? So the next one now, I'll find the summation of this. You know, recall that this one is f of x. This one is f of y. So I will find summation of fx. Then at the same time, I will find summation of fy. Just like the way we find, if you know, at the beginning of this topic, I taught you how to find displacement or the magnitude of two when we have direction like north and south. Please, if you missed that one, just go and check. So here I can easily find my magnitude here. I can find the resultant here. How will I do that? Let me write it here so that. So I can say resultant of these sources, I can use r, that is r squared here. You know, what we have is this. We have summation of f of x, f of y, and f of x. You solve a problem like that. And this is r. So this is theta here. So I can have, if I want to find theta first now, theta the resultant is going to be square root of summation of, just like Pythagoras theorem. This is opposite. This is adjacent, and definitely this is hypotenuse. That's summation of fx squared, summation of fy squared. If I was asked to find directions, I can find directions. This is opposite and this is adjacent. Which one has opposite and adjacent? That is tan. Good. So I have tan theta is equal to opposite over adjacent. You know, theta simply means directions. If I was have to find directions, so here we have tan theta is, so the opposite that we have here is summation of f of y, and the adjacent that we have here is a summation of f of x. So whatever I have after dividing this value by this value, I just find it a tan inverse. Whatever I got, that's going to be my direction. So let's solve like 2 examples here so that we see how we can make how can we approach this problem. You can see that it's simple, right? So nothing hard or difficult in these vectors. It says resolve. I resolve these forces and find its resultant and directions. Maybe we are given a problem like this. Maybe we have this. The first one. It doesn't matter, it can be 3, it can be only 2. Don't worry, I will solve like example like this. That's what I'm saying. 5 Newton here. Let's say we have 30 degree. Let's say we have 10 Newton here, and we have 60 degree. Let's say we have 4 Newton. We have 45 degree. Let's say we have 12 Newton, and we have let's say 65 degree. So now we are asked to find the resultant at the same time its direction. So I can label them anyhow I like. I can say this is my F1, this is theta 1, this is F2, this is theta 2, this is F3, theta 3, F4, and theta 4. I can even make use of this one to do it. Well, let me just write it so that I can understand better. This is horizontal, and this is a vertical, right? Vertical is this. So you know the first one there we have F1 cos theta 1, right? And in this case we have F1 sin theta 1. So let's substitute the values. F1, you can see what we have for F1 here is 5, right? That's going to be 5 multiplied by cos. The theta 1 that we have there is 30. That's our cos 30 degree. So here, if you check your calculator for cos 30 is 0.8660. So please multiply them to have your result. 5 multiplied by 0.8660. What I have here is 4.33. 4.33 Newton. The same thing applicable to that of sine of the vertical. F1 is still 5 multiplied by sine 30. You can see I'm just resolving them. The only difference is for the horizontal we are using cos, for the vertical we are using sine. So that's going to be 5 times sine 30. So you know sine 30 is 0.5, right? So if you multiply this, you are going to have 2.5 Newton. Let's demarcate it like this. So the second one, that's F2 cos theta 2. And here we have F2 sin theta 2. And I told you in the second quadrant, cos must be negative. So that's why we put negative here. So here we have minus F2 I have is 10 multiplied by cos 60 degree. So if you do that, minus 10 times cos 60 is 0.5. If you multiply them, we have minus 5 Newton. So here too, F2 is 10. It is 10 multiplied by sine 60. So now I just have 10 multiplied by sine 60 is going to give us 0.860. If you multiply this one together, you are going to have 8.66 Newton. Now, the third one, let me just clean this side so that I'm under the third one, right? The third quadrant. So I just continue like that. So the third quadrant for the horizontal, for the vertical, right? So I still have F3 cos theta 3. Then here too we have F3 sin theta 3. But we know in the third quadrant, only tan is positive. That's why we have minus here, and we also have minus here. So the F that we have in this case is 4. That's going to be minus 4 multiplied by cos. The angle we have is 45. This one is also 4 multiplied by sine 45. What luckily for us, sine 45 and cos 45 are the same. If you check your calculator for cos 45 and sine 45, your answer will be 0.7071. So 0.7071 is 0.7071. So if I multiply this one together, 0.7071 multiplied by 4. So here, what I have is a minus 2.8284. So here too, we have the same because the two values are the same, minus 2.82, then 84. Right? Nice. So the last one, we are under the fourth quadrant. That's going to be F4 cos theta 4. So here too we have F4 sin theta 4. Now, we know that the last quadrant only cos is positive. So definitely I have to put minus here. My F4 from the problem is 12. That means that we have 12 multiplied by cos. The angle we have is 65 degrees. So here we have minus 12 multiplied by sine 65. I hope you are getting it right. You can see just so simple and straightforward. So now if I check for cos 65, my cos 65 here, what I have is 0.4226. 0.4226. Then for the sine 65, when I check sine 65 here, I have 0.9063. So now, if I multiply this one together, 12 multiplied by 0.4226, what I get here is 5.0712. Then for the second part, minus 12 multiplied by 0.9063. So if I do that, what I have is a minus 10.8756 Newton. You can see how we resolve that. It's just so simple. Just follow the acronyms I gave to you. All science, take, chemistry. In the first quadrant, all are positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. At the same time, in the last quadrant, only cos is positive. So the next thing now, I will now find their sum. The one I have horizontal, the total force I have vertical. You can see the horizontal, we have 4.33 as the first value. We have minus 5 Newton at the second value, minus 2.824 at the third value here. And the last one, I have 5.0712. I'll find them, sum them together. Then the one I have vertical, we'll sum them together. I will now go for resultants. So now, let's sum them together. The one we have for the vertical, at the same time, we have for the horizontal. So summation of f of x, I told you if I use x, I'm talking about horizontal. Summation of f of x, this symbol is summation. The one we have horizontally, we have 4.33 plus minus 5. Let me just say minus 5. The next one, minus 2.8284. The last one is 5.0712. So at the same time, I will also find summation of f of y as well. So that's the first one we have for this. We have 2.5 followed by 8.66 followed by minus 2.8284, then followed by minus 10.8756. So let's find their sum. The first one, I have 4.33 minus 5 minus 2.8284 plus 5.0712. So what I have here is 1.5728. Now I've gotten the one we have horizontal. For the one we have vertical as well, we have 2.5 plus 8.66 minus 2.8284 minus 10.8756. What I have here in my calculator, I have minus 2.54 and 4. So now we have gotten the one we have horizontal. At the same time, we have gotten the one we have vertical. So the next thing for me to do now is to find what? The resultant. So as I told you, we derived the formula together. We said resultant is equal to square root of summation of fx all squared plus summation of fy all squared. So now, by doing that, so here we can have this one to be. So let's check. What do we have for summation of f of x? What do we have there? You can see what we have there is 1.5728 all squared plus summation of f of y, we have it to be minus 2.544 all squared. So just square them and find the square root. If you do that, your result should be the first one 1.5728 squared plus minus 2.544 squared, 2.544 squared. And find the square root. If you do that, your resultant should be 2.99 Newton. That's our resultant. You can see that it's very simple and straightforward to solve. Now I was asked to find direction, so I told you if you want to find direction, direction is theta, the angle theta. I can have tan theta is equal to summation of f of y divided by summation of f of x. Summation of f of y that we have there is minus 2.544 divided by f of x. We are going to have minus 1.5728. So here we have tan theta is equal to, if you like, you can just press it direct. You can see here now theta will be tan inverse of minus 2.544 over 1.5728. So shift tan inverse over minus 2.544 divided by 1.5728. So if you do that, the result will be what we have here is negative. It's because of the value that we have. Depending on the problem, 58.27 degree. So that's all about what we have for resolution of forces. So if you check our materials, we are going to have more examples. It can be it can be 2 vectors. That's why we need to subscribe to our channel, like the videos, and also share so that other people too can be able to benefit from what we are saying. So I will gather more examples apart from this one. It depends on the problem. In some cases, you may have only 2 forces, like you'll be given, let's say we have something like this. You'll be given only this and this. That means you are leaving first quadrant and the fourth quadrant. Just apply the same method. So that's what we have for the vectors. We talk about how to find the magnitude of the vectors, addition of vectors, subtraction of vectors, how to resolve the vectors, at the same time, the angle between 2 vectors. So thanks for watching. That's all we have for the scalar and vector. So please don't forget to like our videos, share, and also subscribe to our channel. Thanks for watching.